Hello friends, are you ready for upcoming Cpet 2022? Here I brings you a video series which explains some practice problem. So let us watch it and enjoy the video content. So let us start question number 1. Here the set A is given as minus of 2n plus 3 by n, where n belongs to set of natural number n. Then which of the following is true? Here the set A is equal to minus of 2n plus 3 divided by n, and the value n belongs to natural number set n. So here the natural number set n comes from 1, 2, 3 dot dot dot. So on putting this value we get the value of A as the set A consists of element here minus of this one is 2 plus 3 by 1 comma minus of 4 plus 3 by 2 comma dot dot dot. This type of element are present. Also on calculating this we get this one is minus 5 comma minus 7 by 2 comma dot dot dot. Here now let us take when the value n tends to infinity, then this one is limit n tends to infinity minus of this one is 2n plus 3 whole divided by n. Then this can be further solved as this one is limit n tends to infinity minus of n into this one is 2 plus 3 by n whole divided by n, and this and cancel out, and when n tends to infinity this becomes 0. That means the final result is minus 2. So here we observe that minus 2 is the bigger number and minus 5 is the smaller number. So here the supremum value of A, this is equal to this one is minus 2, and infimum is minus 5. Now come to question number 2. Here we have to find what is the radius of convergence of the power series summation n equal to 0 to infinity and 2 to the power 2n x to the power n square. Here the series is given as summation n is equal to 0 to infinity. This one is 2 to the power 2n and x to the power n square. This is not in the form of x to the power n. Here n square, the power is n square type. So here let us put m is equal to n square. Then this n is equal to root over of m, and on when n tends to infinity, here m also tends to infinity, and when n goes to 0, this m also goes to 0. Then the final, this summation can be rewritten as m tends to, this one is summation m equal to 0 to infinity, this one is 2 to the power 2 root over of m x to the power m. Now this reduces to standard form. So here we can calculate the radius of convergence by using the formula 1 by r is equal to 1 by limit n tends to infinity an whole to the power 1 by n, and here our limit is goes here our limit is here m tends to infinity. That means we can write this one is 1 by limit, this one is m tends to infinity, and our value of an is here am, that is 2 to the power 2 root over of m and whole to the power 1 by m. And on solving this we get this one is 1 by this one is limit m tends to infinity 2 to the power 2 root over of m divided by m. And on further solving this one is 1 by limit m tends to infinity, this one is 2 to the power 2 by this one is root over of m. And when m tends to infinity, 2 by root over of m, this is equal to 0. So this one is 1 by 2 to the power 0 is equal to 1. So our final answer is 1 by r is equal to 1 by 1. From this, r is equal to 1. So our radius of convergence is r is equal to 1. Hence, option B is correct one. Now come to another question. Here, let V be the vector space of all symmetric n cross n matrix over R. Here given that V be the vector space of all symmetric n cross n matrix, then what is the dimension of V? Here the direct formula is present, that is the summation of n. So we know that the summation of n, this is equal to, this one is n into n plus 1 whole divided by 2. So our option D is correct one. This one is the direct formula. V be the vector space of all symmetric n cross n matrix, then the dimension of vector space V is n into n plus 1 by 2. Now come to another question, that is question number 4. Here we have to find which of the following set is a basis for the subspace W, and W is consist of the matrix of the form x, y, 0, t, and the condition are x plus 2y plus t is equal to 0 and y plus t is equal to 0 of the vector space of all real 2 cross 2 matrix. So from the above option, we have to find which one is the basis for that subspace. So here uh, given that W is of the form, this one is W is equal to matrix are of the form, this one is x, y, 0 and t, clear, and the condition are these are x plus 2y plus t is equal to 0 and here y plus t, this is equal to 0, and dimension of W is equal to, here dimension of W, this is equal to number of independent variable, this one is number of independent variable minus number of restriction, clear. So here number of independent variable, these are three number of independent variable, that are these are x, y and t. So this one is 3 minus number of restriction, here there are 2 restriction, first and second, so this one is minus 2, this is equal to 1. From this we get dimension of W is equal to 1. That means the basis W consists of only one element. So from this, option C or D may be correct. Now comparing the equation, the matrix, this one is x, y, 0 and t, with the matrix, this one is 1, minus 1, 0 and 1. Here we get the value of x is equal to, here we get the value of x is equal to 1 and y is equal to minus 1 and t is equal to 1. And on putting this value in the restriction, we get here x plus, this one is 2y plus t, this is equal to 0. If this value gives us the value equal to 0, then we say that this one is the solution, or this forms a basis. So on putting the value, this one is 1 plus 2 into minus 1 plus 1, this is equal to 1 minus 2 plus 1, this is equal to, this one is 2 minus 2, this is equal to 0. So here this one is satisfied. And similarly for y plus t is equal to 0, then putting the value of y is equal to minus 1 and plus this one is 1, this is equal to 0. Hence this value x is equal to 1, y is equal to minus 1 and t is equal to 1 gives satisfies these two equations, and here we can conclude that here option D is correct one, and this form a basis for the subspace W. Now come to another question. Here the question asks about what is the dimension of the vector space formed by the solution of the system of following equation, and the system of equation are given as x1 plus x2 plus x3 is equal to 0, x1 plus 2x2 is equal to 0, x2 minus x3 is equal to 0. Here we can rewrite these equation in the form of this one is, this can be rewritten as x1 plus this one is x2 plus x3 comma this one is x1 plus 2x2 comma this one is x2 minus x3, this pair is equal to, this one is 0 comma 0 comma 0. From this we can also rewrite this in the form of, this one is x1 into 1 comma 1 comma 0 plus x2 whole into, this one is 1 comma 2 comma 1 plus x3 into 1 comma 0 comma minus 1, this is equal to 0 comma 0 comma 0. Here we observe that for all x1, x2, x3 belongs to R, here we observe that for all x1, comma x2, comma x3, this belongs to the set R, the above equation is satisfied. The above equation is satisfied. So the dimension of the vector space V is 3. Hence dimension of vector space is 3, because for all value of x1, x2, x3 belongs to R, this equation is satisfied. Hence we can conclude that the dimension of the vector space is 3. So here option C is correct one. Now come to another question. Here given that Vn be the vector space, and given that here is the Vn over Zp, where P is prime number, prime number, and Zp is a field. Then total number of distinct bases are, here option A is correct one. This one is the direct formula. You can remember this and apply in problem. That is, the formula is let Vn over Zp be a vector space over the field Zp, then the total number of distinct bases are p to the power n minus 1 into p to the power n minus p dot 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 p to the power n minus p to the power n minus 1 whole divided by n factorial. This one is the correct answer. Now question number 7. Here given that let A and B be 4 cross 4 real matrix. Here given that A is a 4 cross 4 real matrix and B is 4 cross 4 or 4 by 4 or 4 by 4, and given that the relation C is equal to, the matrix C is equal to A square plus AB. Also given that C is non-singular, that means determinant of C is not equal to 0. Then which of the following statement is always true? And on finding this determinant of this was C, this is equal to determinant of A square plus AB, and from this we can write this one is A whole into this one is A plus B, this determinant, and we know that here this can be written as determinant of A into determinant of A plus B, and given that determinant of C is not equal to 0. So here we conclude that this determinant of A this not equal to 0. That means the matrix A is non-singular. So option here, option C is correct one. That is, the matrix A is non-singular. Matrix A is non-singular. Now come to question number 8. Here the matrix A is given as matrix A, this is equal to this one is A minus 1 4 0 B 7, and this one is 0 0 3. Be a matrix with real entries. Then if the sum and product of all the eigenvalue of A are 10 and 30 respectively, then what is the value of A square plus AB? Here observe that the matrix A is of the form of lower triangular matrix, and here we directly we can write the eigenvalues are these are A, B, 3, and also given that the sum is 10, that means A plus B plus 3, this is equal to 10. From this we can write this is equal to A plus B is equal to 7, and also given that the product is 30. So product, this one is A into B into 3, this is equal to 30. That implies AB is equal to 10. So here two equation we can conclude, and we have to find what is the value of A square plus B square. So we have to find what is the value of A and B first. That means A minus B, this whole square, this is equal to A plus B whole square minus 4 times AB. So A plus B whole square, this one is 7 square minus 4 into this one is 10. That means this one is 49 minus this one is 40, this is equal to 9. And from this we can write this one is A minus B is equal to root over of 9, this is equal to 3. So here we get two equation is A plus B, this is equal to 7, and A minus B, this is equal to 3. And on solving these two equations, we get the value of A is equal to this one is 10 by 2, this one is equal to 5, and B is equal to this one is 7 minus 5, this is equal to 2. So here we get the value of A is equal to 5 and B is equal to 2, and we have to find the value of A square plus B square. This is equal to this one is 5 square plus 2 square, this is equal to 25 plus 4, this is equal to 29. So option A is correct one, that is 29. Now come to question number 9. Here given that y1 and y2 be two linearly independent solution of the differential equation x square y double dash x minus 2x y dash of x minus 4y of x is equal to 0, and x lies in between 1 to 10. Then consider the Wronskian w of x, and here given that w of 1 is equal to 1, then what is the value of w3 minus w2? So here our differential equation is given as this one is x square y double dash minus 2x y dash minus 4y, this is equal to 0. In this type of differential equation we can rewrite this equation by putting the value, this one is log x is equal to z, or x is equal to e to the power z. On substituting this equation, we get the differential equation is of the form, we can write this one is x into d by dx. This can be written as d dash, and this one is x square d by dx square. This is equal to d dash whole into d dash minus 1. And on putting this value in this equation, we get the rewritten form of this equation is d dash minus 1 whole into this one is d dash. So x square y double dash, this can be written as this, minus x y dash can be written as d dash. So this one is minus 2d dash minus 2d dash minus 4 whole into y. This is equal to 0. So on solving this, we can write this one is d dash square minus 3 d dash minus 4 whole into this y is equal to 0. And we can solve this differential equation by using auxiliary equation, and factorizing this, we get this one is d dash minus 4 into this one is d dash plus 1 whole into y is equal to 0, and the roots are d dash is equal to 4 and this d dash is equal to minus 1. Hence the solution of this differential equation y of x can be written as c1 e to the power minus z, and this one is we can write the first solution as y1 of x, and we can write the second solution as y2 of x. This is equal to this one is c2 e to the power 4z, and the final solution is y of x is equal to y1 of x plus this one is y2 of x. Now here we have y1 of x is equal to c1 e to the power minus z, because we write log x is equal to z, and from this we can write x d by dx is equal to d dash, and the value of d dash, this is equal to this one is d by dz. Clear? By substituting this, we can rewrite this differential equation in the form of this type of equation, and this one is the auxiliary equation, and we can write the roots as d dash is equal to 4 and d dash is equal to minus 1, and the solution are this and this. So on substituting the value of z, we get the y1 value, or y1 of x, this is equal to c1 divided by x, and here y2 of x, this one is c2 x to the power 4, and also given that here the Wronskian w of x is equal to this one is y1 of x into this one is y2 of x, and Wronskian is y1 dash of x and y2 dash of x, this quantity determinant, and here given that these are the linearly independent, that means this Wronskian is not equal to 0. And on substituting the value y1 of x and y2 of x from this, we get the value as this one is c1 by x, and this one is c2 x to the power 4, and the differentiation of this one it gives minus of c1 divided by x square into this one is 4 c2 x cube, and this determinant, and on solving this determinant, we get this one is 4 c1 c2 x square plus this one is c1 c2 x square here, and further solving this gives this one is 5 c1 c2 x square. Clear? Now here also given that W of 1 is equal to 1. Given that W of 1 is equal to 1. W of 1 is equal to 1. That means on putting the value of x is equal to 1, this gives this one is 5 times C1 C2, this is equal to 1, and from this we can write C1 C2 is equal to 1 by 5. C1 C2 is equal to 1 by 5. So on putting the value of C1 C2 is equal to 1 by 5, we can write this W of x is equal to this one is 5 into C1 into C2 is equal to 1 by 5 into this one is x square. So 5 cancel out, given as this one is x square. That means the Wronskian W of x is found out as x square, and we have to find the value of W of 3 minus W of 2. So simply putting the value x is equal to 3, this one gives 3 square minus 2 square, this is equal to 9 minus 4, this gives 5. So here correct answer is option number D. So option D is correct one. Here the sequence xn is given as this one is xn, this is equal to 2 to the power 2n whole into 1 minus cos 1 upon 2 to the power n, and here n belongs to set of natural set n. Now we have to find whether this sequence is converges or diverges, or what type of behavior. So we can rewrite this, the sequence xn is equal to this one is 2 to the power 2n whole into 1 minus cos theta, this can be written as 2 sin square theta by 2. So this one is 2 sin square theta by 2, that means 1 by 2 to the power n plus 1 and bracket close. Further rewriting this, this one is 2 to the power, this one is 2n plus 1 and sin square 1 by 2 to the power n plus 1, and let us take this as un is equal to 2 to the power 2n plus 1 and sin square 1 by 2 to the power n plus 1, and we have to find what is the limiting value. That means we have to find whether this one is converges or does not converge. So limit n tends to infinity, this one is un plus 1 and un, we have to find this quantity. So this is equal to we can write here, this one is limit n tends to infinity, this one is 1 by 2 into 2 to the power 2 into n plus 1 into this one is sin square 1 by 2 to the power this one is n plus 1, and further this can be written as limit n tends to infinity and 1 by 2, this one is sin square 1 by 2 to the power n plus 1 whole divided by this one is 1 by 2 to the power this one is n plus 1 this whole square. Clear? And here we can write this one is sin square 1 by 2 to the power n plus 1 and 1 by 2 to the power n plus 1 whole square. So this quantity can be whole to the whole square, and we know that this limiting value this is equal to 1. So this can be rewritten as this one is 1 by 2, or the value is 1 by 2. That means this sequence is converges to 1 by 2. So here this one is converges to 1 by 2. That means option C is correct one.